The next thing we'll do is revisit Newton's method that we looked at last week and change the for loop into a while loop eventually. So just to review, we set up an inline function that was x minus cos of x. We also set up an inline function for the derivative that was 1 plus sine of x. We had an initial guess of 1, and we wrote the Newton's method as new iteration equals last one minus f of x at x sol divided by df dx, also at x sol. Okay, we hit calculate and we get one iteration of Newton's method. Then we put a for loop around this solution so that we could iterate more than once. So for, let's say, counter is equal to 1, I think we did 1 to 3, I'll do 1 to 5 because I'd like to see a few more versions of the solution. Finishing that for statement with the end statement. Let's clear the output and calculate again. Okay, there you go. 5 iterations of Newton's method, and it looks like pretty quickly the solutions converged at least within the number of decimal places that were being shown here. The next thing that we'll do is change the for loop into a while loop, and then we'll look at changing the while loop so that it will stop iterating when we reach a certain tolerance of the solution. So when the solution stops changing within a given tolerance, we'd like to stop iterating. Okay, so first I'm going to set this up to be a while loop using the counter. Don't forget that we need to set the counter's value before we start the while loop. Change the for to a while and change this statement into a logical test condition. So we're going to test whether or not counter is less than 5. And most importantly, within the loop we have to change the value of the counter. Okay, clear the output, recalculate, and we should see the same thing happening.